yesterday we kind of left off, we just went through, well, you found your standard deviations in your calculator, and using your L1, if you can't find your variance, take your standard deviation, square it, because it's the opposite of what we did with the table. Now, I'd like to go back to your normal curve, because really this course centers around this normal curve. So this is really important that you get this. We use the same percentages, of course, that you saw in Algebra 2 on your formula sheet. And in Algebra 2, they were kind of separated by halves. We don't have to do that because soon we will learn how to find any standard deviation on here. By the beginning of next week, or maybe the end of this week, we will be finding any of them. So we don't have to separate them any further. But by this chart, and your empirical rule kind of estimates this. Where before we kind of got a little bit more exact in adding all those percentages, we even added all the decimals, your empirical rule estimates. It says between 1 and -1, you have 68% of your data. That's over half. That's a large amount of your data. Varying one standard deviation below the mean to one standard deviation above the mean. So say, for instance, I give a test in here. The average of the test is 75, and my standard deviation is 5. If I put this here, and I go up, that means the majority, 68%, almost 70% of the kids, score between this, in a heterogeneous group.
I don't mean to interrupt class.
Go ahead.
Yeah, but is it always going to be 34%, 34%?
Yes.
So always, there's never going to be like a change in that?
No, this stays constant because the whole area under the curve represents 100%. Now, if you think about this, when you come to the curve here, don't you have a small section? So these are small. Our curves look a little bit bigger, but in reality, they're probably a lot more narrower. Like this is really more narrower by the time you get out here. There's only 3 sections that we chart. But by the end of this week, we'll be finding exactly 1.3 standard deviations. We'll be finding those with formulas, so we don't have to get any more exact than this. But we do have to know that this whole area adds up to 100%. And the majority of the data falls here. Isn't that the biggest chunk of your curve? Right?
Yeah, you're right. Yeah.
If you made a hill, the biggest part of your sand goes right in the middle, right?
First deviations are always going to be the largest.
These are going to be the largest. Now, as we spread out, we add this, we add this. So, for 1 plus or minus 2, we've got 95% of your data. Approximately 95%. Approximately 95. That's most of your data right there. And so therefore, the kids in my class that scored 85, 65 to 85, 95% of my kids I expect to score between there. If this is totally like heterogeneous. If you're not, like, you guys are on the smarter side, so my scale doesn't usually go normal curve. It's usually skewed to the higher ones.
Are you calling us smart?
I am, which it should. You're a college level class. You should be scoring higher. Then your plus or minus 3 is almost all of your data. Look how small this is out here. If there's only 0.3% left, this is only half of this. This is 1.5% out here and 1.5% out here. Think of your standard deviation scores, because that's probably something that does follow a bell curve. 1.5% of your kids, of a whole population of everybody that took the SAT, scores really high. Scores very high. So it's kind of like, what are your chances of winning the lottery type thing. 1.5% score really low. They probably just put their name on it and just guessed at every question because they couldn't be bothered doing it. But and it happens. I practiced the PSAT. There was kids in my group that were just filling in, putting their head down, filling them in. I'm like, you have to read this. If you opt to come take this, you walked into school today to take this test, at least read it and give it a good try. Well, my mother made me come. So they just sat there filling in the circles. I had one girl slept through the whole thing. She filled in maybe 3 circles through the whole thing. Now, and that looks worse counting against you.
I was gonna say, is it like on the SATs, where they like omit the questions that you don't answer?
Well, they give you like no points for the questions you don't answer, and like a quarter point wrong for the one quarter off that you get, but your scores still range from a certain point to a certain point. Like there's a certain amount, like you can't get a 0. I think the lowest you can get is like 200.
That's the only way to spell your name right.
It's, well, if you didn't answer anything, because you're not charged for any wrong answer, for anything that you omit, but you are charged for wrong. But if you have no points to accrue, I think the smallest score you can get is 200. But your scores would go from the 200 to whatever your highest is, 2,000. I don't know what the highest is.
Like 800 per section.
800 per section, you have 3, so 2,400. Okay, so they would chart it from here to here. So very few people are scoring down in the 200 range.
Well, it would be 600.
Hmm?
It would be 600.
600 is the lowest you can get?
Yeah.
Really?
Right?
I guess that's true, because it used to be 200 when they did 2 sections.
Isn't it 200 per section?
Oh, could very well be.
And you get a certain amount for each range.
I know 200 kind of
If I
stuck in
tell
my
my mom
mind.
I got a 200, she'd be happy because then she could ace the test twice.
See that?
So I can't tell, you guys don't tell my mom this, okay guys?
All right, so now, when we look at your standard deviation table, remember that the 0 is in the middle. The 0 is in the middle of your standard deviation. So then we're going to take a look at how do we exactly use the standard deviation chart. And we're going to take a look at this first before we get into your formula. So example 7 says, in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the U.S. ages 20 to 29 was 64 inches with a sample standard deviation of 2.75. So you pull out your information. I have a sample of women ages 20 to 29. They come from all women, of a population of all women ages 20 to 29. We want to estimate the percentage of women whose heights fall between 64 and 69.5. We want to estimate what percentage falls there. So the first thing we do is put this on our curve. Separate them into 3s. Right now you only know this much. You only know this much of your curve. So you're going to separate them, and you're going to put your mean smack in the middle.
Can I answer this question on the board, Mrs. Morris?
Can you answer it on the board? You know this answer?
I know how to do this from what you taught us. You're a great teacher.
Here on.
Guys, watch the man. So,
Explain to the class what you're doing. Other part.
34%, right? 34%.
34.
That looks like a
13.5.
13.5.
2.35.
2.35.
Wait, am I missing one? 2.35.
Alright, right? Standard deviation is 2.75. So 64 plus 2.75 is 66.75.
Yep. I'll be your calculator person.
And then another 2.75, that'll be 69.50.
Wow, congratulations. You're doing a great job.
Thank you, sir.
Good.
Honestly, just fantastic.
Thank you, sir. I appreciate
Okay,
your
let's
enthusiasm.
keep this going.
Alright, and then on this side,
No, do one more,
one more?
just for the heck of it.
Okay, just for the heck of it.
72.25.
Thank you. 72.25.
Good.
I call you.
And let's reverse the other way. You see what he's doing? He's taking the standard deviation, adding it.
72.25.
After 34, what are the percent numbers?
34 is 13.5
And then
2.35.
Okay.
So go the other way, it's 61.25.
Then hold on. I'm a mathematician in my brain. It's a 0.5. I know that much.
It's 58.5.
See, I knew.
And one more, 55.75.
55. What?
55.75.
Wow.
Okay.
And then from here all the way to 69.50. That is 34.5. 34% plus 13.5%. So that'll be 47.5% of the women are in between 64 and 69.5 inches. I am done with this class. Give me an A plus.
Okay, very nicely done. Okay, does everybody understand what he did? This is really important that you get the bearing for this curve. This is a normal curve. It's saying things spread from the middle on a normal curve. Not everything in life works on a normal curve, but when we can use it, we can apply this rule. Now, when we get this percentage, what this percentage says is, I don't really know how many they did. I don't know how many fell in between there. But if they fit the normal curve, I can approximate what percentage of those women fell between 64 and 69.5 inches. I can also say, if I did another sample of 200, I would expect 47.5% of the 200 to fall between 64 and 60.
Now, how do you know if it's follows the normal curve?
Well, because normally it has to tell you that it approximates the normal curve. Since this exercise is all about that, we're assuming that it does, and it might, and I might not have written it down. Yes. Do you see that? It says because it approximates the normal curve. It says it in the solution part. It should have said it in the above part. Normally, you'll see that it says approximates your normal curve, but that's a very good point. So we're just putting our data right out here. So I want everybody to try, and since Darian already labeled all of these, I want you guys to tell me what percent falls between, so you found it. So you guys are very good about this. Good. So 34% is falling between 61.25 and 34. Okay. What percent falls between 58.5 and 66.75 without adding anything up? Without adding it up. Quick.
Oh.
Who's quick?
What? What's the question?
85%.
Oh, 69. Sorry, 69. Let me change this.
You didn't even
Yeah, I know. What percent, because this makes it easier. What percent falls between 58.5 and 69.5? 95. Good, 95. That's your curve. What percent falls between 55.75 and 72.25? 99.7%. That's your plus or minus 3. So the majority of your curve is falling in here, and it's an even symmetric curve. Good. Okay, now, since life doesn't always work that way, we have Chebychevs theorem. Chebychevs says it's not always representative of a normal curve. Sometimes it's skewed, such as this class. Your grades are generally higher than they are lower, so it doesn't really follow a normal curve. Now, with Chebychev, we can not fit his into this curve, so he has his own kind of thing that he comes up with, and he really can only do 2 or 3 standard deviations above the mean. This is what he's looking at, and that's okay for us too. So we have this little formula for Chebychev, which you're going to have to know, and in this formula, we determine what the standard deviations are with the mean, and we determine the old-fashioned way how many standard deviations above the mean. So say, for instance, my mean is 80, my standard deviation is 5, and I have a score of 90. I am 2 standard deviations above the mean. I have to determine that first. Then that 2, we plug into this formula. So he estimates, let's show you this way. Here's the 80, 85, 90. Here's my 2 standard deviations. My 2 standard deviations says I should have 95% of my data. But now I'm determined that this is not a normal curve. So I find my 2 standard deviations. I want to go from here. I find my 2 standard deviations and I plug it into this formula. When you plug in the 2, you get 4. So 1 minus 1/4 is 3/4. So instead of 95% of this class, I'm going to say 75% of my class falls between here. It just gives me a little bit of leeway because this is not a normal curve. So now I'm going to say 75%. And he can only do 2 and 3 because if you put a 1 in here, a 1 is 0 here. 1 squared is 1. This will give me 1 minus 1. I get 0. I get nothing. So he can't go that low. He can only do, Chebyshev can only do a 2 or 3 standard deviation. So now if I say my plus or minus 3 should be 99.7%, if I'm from 95 to 65, I should have 99.7 because it doesn't fit a normal curve. I take my 3 and I plug it in here, and I come out with about 89%, 88.9% of the data. So where I would say 99, I'm saying 89, 88.9%. It gives just a little bit less. It errs on the side of, I don't really know where your curve is skewed to. It's just any curve that doesn't follow a normal curve. It could be that 95% of my class does fall into that range, but because it's somewhere not normal, I have to use this theorem. And that's all we need to do. We only look at this once. The rest of this course is the normal curve. We never go back and look at Chebyshev again because his curve just gives us the exceptions. So if you take a look at example 8, it says apply Chebychev's theorem to this data for Alaska using k equals 2. That means they found the standard deviation to be within two standard deviations of the mean. Because his curve is not normal, we're just going to plug his values in here. He uses, they kind of give you, they don't really give you a graph to look at this, but if you take a look on page 81, you can kind of see the skewness in the graphs. You can see they're kind of skewed a little bit. So if you're taking a look at this, you can see which one is Florida, which one is Alaska, and kind of take a look at this. The problem with this guy is we really can't tell where the curve is. We're not always given a graph. We're not always given how your data is. So this is such a rough estimate that he only just sticks to the 2 and the 3. It's kind of like a one-size-fits-all thing. It's always going to be those two things. It's not going to vary. And we're not going to check the 1.5 or the 1.7 when we get into that. We're only doing it with the 2 and the 3. So if you take a look at example 8, example 8 says the age, it's right on page 81. The age distributions for Alaska and Florida are shown in the histograms. So it shows you that the histograms do not follow a normal curve. Decide which is which. So right away, what can you decide? Which one do you think is Florida? Which one do you think is Alaska? Knowing what we did from the Alaska ages.
The right one is Florida.
The right one is Florida. What gave you that good hint?
There's more older people.
There's more older people. We remember from our ages in Alaska, there were less older people. They didn't like the cold. So now, we're going to say, we're going to apply Chebychev's theorem to the data for Florida using k equals 2. So you can tell this population is older, and you're moving 2 standard deviations, and you can figure out what they are. But if you follow this reasoning, go look at their solution. Moving 2 standard deviations to the left puts you below 0. That really doesn't happen. But that's the closest guesstimate we could take for this. So really negative 10.4 never happens in your ages, but that's the closest we're going to get. Moving 2 standard deviations to the right puts you at 88.8, which really is covering your whole chart. But we're going to say, using his theorem, because I really don't know what this graph looks like, I'm going to have to use the 2 and come out with 75% fall between 0 and 88. So it's kind of like, even though you can visualize the chart, we don't really know what that chart looks like in real life if they tell us this. But if we apply this rule and we go 2 standard deviations off of our curve, here's your mean, here's your two standard deviations up, add 24.8, add 24.8, and they got 88 point something. Come two standard deviations down, they're negative. This doesn't happen. So we know something's wrong with our curve. So we apply Chebychevs theorem, and all we can say is this, a very standard way to do this. This is 1/4 again. This is 75% of my ages will fall here. Even though you can pretty much see it's 100% of your data. We can't give it that 99.7. We can't give it the 95. We can't give it the 68. We'll never get the 68. That's too low for them to zero in on. So Chebychevs has a very, very one-size-fits-all type of thing. It's not that that's very normal. And we're not going to really work with that in this whole course. We're going to stick with the normal curve. But I do want you to realize that all data does not fit your normal curve. And since it doesn't, for our purposes, we can't get any more exact. This is like a course in itself. If you continue with statistics and you major in statistics, this is a whole course of study in itself. Things that do not fit your normal curve. This is very, very hard to figure out what to do with it. So Chebyshev kind of has just like a generalization for this, like a one-size-fits-all. So let's take a look at, excuse me, let's take a look at his, if you're a try it yourself 8. He says, let's do this for the Alaska ages. So the Alaska ages, they give us, work with me here guys, they give us a mean of 31.6 and a standard deviation of 19.5. These are your Alaska ages. And they want to know what percentage will fall within two standard deviations of the mean. So we're going to start like this. We're going to start off of your curve, 31.6. We're going to go up 2, and we're going to go down 2. So let's do this with me so that you get a better understanding. We can see by the Alaskan curve, we can see where their ages are. And you can see that that doesn't fit a normal curve. So the first one is 51.1. And then 70.7. And then we're going to drop it down. You need to do this part first. 31.6. And do you ever expect to find a person negative 7.4? No. So it tells us right away something's wrong with our curve. And they're going to tell us that it is not a normal curve. It does not fit your normal curve. So once we know that, we want the ages from here to here, which is basically 0 to 70.7. We want to know what percentage falls in there. So normally we would say 95%, but we can't say that.
88.9.
So did he want 3 or 2? He wants only 2. He wants only 2. So normally we would say 95, but because this doesn't fit a normal curve, we revert to his formula. And we say it's 2 standard deviations above the mean, plug your 2 in. So again, this is 75% of the people will fall between here. It's very generalized. If we did 3 standard deviations, we add 1 more to here, and we would cover all the people in that chart, and we would still come up with 88%. It's just a generalized, but we can see from the chart that it covered everybody. But he's got a one-size-fits-all package here. This is the only time in this whole course we look at something that is not a normal curve. The rest of this entire course works off of your normal curve. He just gives us a little tool to say, what if this isn't a normal curve? So we're very generalized in saying it's either going to be 75% or it's going to be, if it's 3 standard deviations, 88.9%.
So you only use, like, if we're going to take the test on this, like, next week or something, we only use this when we know the curve is not known.
Yes, and I would tell you that you have to use that. Yeah.
Did you get the performance everything?
adding your standard deviation. Always start with your mean and add your standard deviations. So even though this was not a normal curve, I put it on a normal curve so we could see what's our to and our from.
Where'd you get
This information out of the book on the bottom of 81. On the bottom of 81. I just did it with the Alaska people. The Alaska, it's right in your chart. Look at the chart on the left. There's your mean and your standard deviation. Okay? All right. So I'm going to give you guys some problems to do.